Right. This is the lesson where we're going to go over how to work with multiple triangles. And again, sine law, cosine law are both always present or at least applicable depending on the scenario. And here we are. We're going to go over this, so make sure you write this down. These questions are a bit more difficult to solve. In general, I kind of suggest you follow the following steps, right? Fill in what you can tell without solving, right? You may have to use complementary or supplementary angles if present. Start with a triangle with the most information, right? That's important, right? Start with a triangle that has the most information, basically. That's very important. Solve for the side that is shared between the triangles. Solve side that is shared, okay? Now solve for the side required to answer the question. Okay, so that's basically the order that I would suggest you do it. Okay, some of you are going to find as you work through these that there are more ways to solve it. That's fine, nothing wrong with that. But I will kind of stick with the script here. Right, so we have the following example here. The angle of elevation to the top of a tree from point B is 42 degrees. Okay, and it's already there. From point B to the top of the tree, it's 42 degrees here, that angle of elevation. That's where it's supposed to be. From point C, which is 70 meters closer, right, that's also labeled. The angle of elevation to the top of the tree is 58 degrees, which is exactly where we want it, right here. And how tall is the tree? So the ultimate question is this, right? Like, how tall is that tree? And so that's what we're gonna attempt to solve. Just look at it this way. If you want to go straight to this, to either the big triangle here that involves the height, or if you wanted to use this smaller one here, in either case you do not have enough information, right? On this big one here, you don't know any of the three sides. Yes, you know part of it, part of the base here, but not the whole thing. And even if you were to cut it here and just try to solve for x, all you have is an angle, so you're stuck. So that's what I mean with fill in as much information. That'd be step one, using complementary or supplementary angles, right? So here it is again at that point right there, right? If you zoom out, if you say, hey, at that point I noticed something, right? I noticed that if this is 58, right, then whatever's on the other side has to, together they have to add up to 180. So 180 minus 58, right, because you know 58, that's 122 degrees. So you know that this is 122, and combined they give you the 180. So that is exactly what you want. You want this angle right here, okay, which goes right there. So we'll put the 122 there. Now we've been able to bring an angle inside this triangle here. This is an obtuse triangle right here. And that's perfect because I do know one of the sides of this triangle right here. Okay, and now let's see, what do we have? We have two angles and one side. No pair, right? And but you can also not use cosine law, because cosine law you need all three sides, or you need side, an angle, and a side. You don't have that either. So, but we still are able to find this one up here. So that angle up there, we can easily find that using the sum of triangle, and that one is across from this side, which will allow us to get a pair. Okay. So this would have been step number one here. This little step there, and then I would probably make this step number two in this case. We're going to figure out what that angle is. That'd be 180 minus 42 minus 122. Okay, and that gives you 16 degrees. So that's step number two here. So now we know that this is 16. We have a pair, and we can start solving now. Okay, so I'm going to go sine of 16 degrees over the side across from it, which is 70, is equal to sine of which one should you solve for? Because if you grab 122, you solve for that one. If you grab 42, you solve for this side. I will recommend you solve for the side that is shared between the triangles. It is possible to use the other one, but I'm going to say here this. I'm going to call this, maybe you can call this lowercase b, but then you have an issue with d being here, so I'll just call this side y. Okay, so sine of 42 degrees is, right, this angle is across that side. So there we go. And we solve. And we cross multiply and divide. So it's 70 times sine of 42 divided by sine of 16. And y is 169.93 meters. Okay, we're not done yet. This is just part of the work. So I would consider all of this step 3. And some of you might not think of it as steps. You're just doing it automatically, but I just want to kind of show you how I did this, in which order I went. Okay. Then the next step. Now that you found this one, you can actually work with this triangle because you know one side, right? And so my fourth step will be to do exactly that. Cut it like this. There's a 90 there. The height is always measured at a 90. That's the x that I want to find, which is the tree here. And the y is 169.93, right? I know that. And I also know this 58 is actually comes in handy, right? It comes in handy because it's right there. So that's my last step. We're almost done here. You can cross, this is your pair. So sine of 90 degrees over 169.93 is equal to sine of 58 over x, right? Which is what we want. So x is equal to, we cross multiply, right? 169.93 times sine of 58 divided by sine of 90, which is just 1. And that gives us 144.11 meters. Okay, this is the ultimate answer. That's the height of the tree. Height of tree. Okay, you're done. So we used multiple triangles here to kind of slowly work our way to the final answer. Okay, I will highlight this yellow one here because that was crucial, right? That was like my first go-to before I solved for the height of the, so there you go. You had, you know, actually there's, if you think about it, there's more than 2 triangles, right? There's the big one here, there's this one here, and then there's that one there. However, just focus on finding the side that kind of splits those triangles. That's the shared side. And then move on from there, okay? Okay, so this is it. I'm going to keep going one more example. If you feel like you got it and you want to start working through it yourself, I'm going to tell you that we're going to go all the way to page 42 at least. Okay, so you can go ahead and work all the way to page 42 already. And so here I am. I'm going to do one more example. Hayden and Belinda are hiking when they notice people rock climbing on a cliff. So I'm using the names, right? Aiden is here, Belinda is there. They're hiking and notice people up on a cliff. They want to estimate the height of the cliff. Okay, that is actually kind of giving it away already. Like, hey, I'm going to probably have to find the height of this thing. Aiden estimates the angle of elevation to the top of the cliff from its location to be about 45 degrees. Oops, that is a typo. That should have been 35. Just go by the diagram. Need to fix that. So it's 35 degrees. Belinda, who's 15 meters closer, right, to the cliff, estimates the angle of elevation to be 50. Okay, So there you have it. I would say the diagram trumps what says on in the word problem usually. That's the safe method. So let's see here. Determine the measure of ABC. So ABC, right? They're asking for this angle right there. Let's maybe highlight that, right? That angle is this one right there. So we know that's 130, right? So we don't really need to do a whole lot of calculating there. It's 130 degrees. And the angle C up here is 180 because the whole triangle adds up to 180 minus the 35 because right now we're in this triangle here. We're going to make this 130, right? So we're going to take these two away from 180 to get that sliver up there. So this would be 165. So that leaves us with 15 degrees, right? Angle C is 15 degrees. And ABC, which is what they're asking us, 130. I don't know, maybe we can do this, right? The 15 here is right up here. And it pairs up with that side right there, which is good. That's what we want. Maybe highlight this, right? 130 is right there. So it all adds up. So this is 15. We have our pair. So calculate the height of the cliff. You want to go straight to the height of the cliff. So remember, the height of the cliff is measured straight down, and there's a 90-degree angle formed. Okay? So we can't do that straight in one step. Okay, you can't do that. It's the same as the previous example, because if you grab this triangle, you know no sides. If you grab the big one out here, you also don't know any of the three sides, even though you know part of the base. So we're going to proceed the same way. Just start with your pair. There's a little bit, this is going to be a bit crowded, so I'm going to be conservative with my space here. Sine of 15 over 15. And I'm going to pick the 35-degree angle to figure out the shared side, right? This one right here. So I'm going to call that Y, because the ultimate is the height, right? We can call that H. If you don't want to call that X, that's fine. So sine of 35 is across side Y. We solve for Y. 15 times sine of 35 divided by sine of 15. And if I go too fast, you can slow me down, right? So 15 times sine of 35 divided by sine of 15, that's 33.24 meters. So that's the highlighted one, right? That's the one that is shared between the triangles. And then I'm going to cut out this triangle right here. I'm going to grab the 50, put that in here. This is a 90. This is my height. I just figured out that this is 33.24. Okay. And I have a pair. And I can find the other one. So sine of 90 over 33.24 is equal to sine of 50 over h. Cross multiply. That is 25.46 meters. Okay, so that's the ultimate answer, right? So I can highlight that orange. That's what you did there, right? So this orange side is what we solved for. So we needed the supplementary angle here, right? We needed to use the straight line to get the 130 into here so that we can find 15, and that allowed us to have a pair. And then we kind of started here, found the shared side, and then found our way back to that triangle right there. Okay. Next, so I'm stepping it up. So how far from the base of the cliff is Belinda? So they're asking for, we can call this maybe side X. They're asking for this stretch right here. So we can actually, there's several ways of doing that. You can use this one here. So basically, this is where Belinda is right here. And we know that this is 3324. And this is 50, correct? If this is 50 and this is 90, right? You know that if this is 90, then these two add up to 90 as well, because 90 and 90 add up to 180. So this one here, this one up top is 40 degrees, okay? Just think about it, that the sum of triangles. So that will allow me to solve for x. So you can still use this pair, sine of 90 over 33.24, and then you can go sine of 40, right? Sine of 40 over x. So I did not use the 50, which gave me the height. I'm going to use the 40 up here to find the how far Belinda is. So it's 33.24 times sine of 40 divided by sine of 90. Let me just figure that out. It's 2137. And that is in meters as well. So figure that out. Okay. Not going to highlight because I don't have any more colors, but there it is. And how far from the base of the cliff is Aiden standing, right? So they want to know from the base of the cliff to Aiden, what's the distance? And the answer is just add what you just found, which is x, to 15, right? So it's 2137 plus 15. That's 3637 meters. That one was easy, right? So there's that. If you want more, I mean, I told you to go all the way to, I will say homework, page 40 to 42. And the answer key should be posted. Same idea here. Actually, this may look similar, but there are no angles given anywhere here. So side, 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 go figure. You're going to have to figure out, start solving, and then keep moving on, right? And then you have the shed example here. And you have the building on top of a hill. You should notice that, right, there's a dashed line going straight to the ground here, and it makes a 90, right? So all the way to 42, and that's it.